In a previous video, we talked about the structure of the substrate, and let's do some recap. We said that, for example, for SN2 reactions, the reaction is faster for primary alkyl halides. It's faster than for secondaries, and tertiary pretty much don't go. We have that. Tertiary substrates under those conditions rather do elimination reaction. Now, in the case of SN1, and SN1 and E1, remember, go through the carbocation intermediate. And as we have studied before, carbocations, that I have previous videos on that, but if we have a carbocation, typically, if these are 3 R groups, say 1, 2, 3, that it will be a tertiary carbocation. This is more stable than, say, a secondary carbocation, and by far more stable than a primary carbocation. Right? So because of that, the order of reactivity of both SN1 and E1, because this intermediate is a common step in both mechanisms. So here reactivity is tertiary substrates react faster than secondaries, and primary pretty much don't go that way, unless the carbocation can rearrange. That's an exception there. Now I want to mention a couple of structures that we didn't mention before when we were talking about the structure. So in these are other substrates such as, say, this one, which is allyl bromide. This is benzyl bromide. And let's contrast that to this. And now notice that here the leaving group is directly attached to an sp2 carbon. So, and now this. So this substrate we're gonna find a lot in the when we're doing problems. So here notice that the leaving group is 1 carbon away. So this is allylic. So again, these two positions are vinylic. Next one is allylic. So, and that's where the bromine is. Here, the bromine is directly attached to one of the 2 carbons in the double bond. So it is vinylic. Vinylic halide. This one here, notice, is 1 carbon away, not directly attached to the ring. This one is directly attached to the ring. So we call that aryl. In this one, we call benzylic. These structures are important because, for example, vinylic and aryl structures are very unreactive towards SN2 and towards SN1. Either way. But, however, allylic and benzylic substrate react very well, both via SN2 or SN1. The reason for the reactivity under SN2 conditions is that, remember, that's your alpha carbon, so it is primary, and we know that primaries react much faster than secondary. This is also primary, so they are good as primary. Let me just erase that. I need a little bit of that space. I was saying this is tertiary in the other example, right? Secondary, primary. Okay, so here, allylic, benzylic, we said that they are very reactive under SN2 conditions. Because again, those 2 substrates are primary, and so there is not much steric hindrance. Now, this is opposite to what we have in vinylic and aryl. And also, this type of reactions do not happen at carbons that are sp2 hybridized. This is sp2. This is also sp2 hybridized right here, where the leaving group is. So fairly unreactive for these type of reactions. Now, allylic and benzylic are also very much reactive under SN1 condition. And to explain that, I'm going to draw, remember that we said that Could move the books, and then I make that too dark. Okay, so remember that SN1, E1, they both go through a carbocation intermediate. So you leaving group the parts and you form a carbocation. So now we're going to draw the carbocation that results after this, the parts. So leaving group is going, and now you're forming for this molecule, you're forming this carbocation, that is an allyl carbocation, and here you're going to be forming a benzylic carbocation. These are stable carbocations due to resonance. Remember, we have studied that before, that you can do resonance structure if you move those electrons. Remember, a positive charge in an allylic position to a pi bond, and you will form the following resonance structure, these two. And these two contribute a lot to the hybrid. So the stability of the carbocation due to resonance make this compound very reactive under SN1 condition. Similarly happens with benzylic. Benzylic carbocations can also be stabilized by resonance. I'm going to draw just one of the resonance structures, but there's several, and I'm sure you can do them all. So here you have one, but you can continue doing that. Remember, this positive charge is allylic to these pi electrons, so you can continue doing that. There's more resonance involved there. So again, carbocation is stable due to resonance. So we need to add to the list of reactivity the allylic and the benzylic halides. And these two structures react well via SN2 and SN1. And we need to remember that the case of the vinylic in the aryl halides, they do not react under those conditions.